guys, we have something special today. How about an NSX? This is VTEC Academy and you're about to get schooled. All right guys, I am here with Ravi Tomerlin from We Don't Lift Racing. You guys specialize in safety equipment.
Safety equipment and go fast parts for race cars.
Go fast parts. So we have his NSX here. Now this NSX isn't any NSX. This actually is the first NSX with a K20C engine swap in it.
Correct.
Yeah. Ravi and I, was it over beers one night?
Taco Tuesday.
Taco Tuesday.
Taco Tuesday got us.
Yeah. Started talking about what we wanted to do with this car and
2018, I think, right?
Yeah.
2018.
And we decided, you know, people had been switching the K20A and the K20Z in these cars, and I didn't like that idea at all. I thought that the Type R motor was just going to be a much better choice.
Yeah. We thought it's a better packaging, factory turbocharged, a lot of power potential, and not really messing up the original setup in there. We didn't have to cut anything, we didn't have to change the trunk or deal with any of that stuff. So let's check it out.
Yeah. So anyway, we're going to take a look at the car.
So I picked up this car in 2013 with the intention of using it for Super Touring 2 with NASA Arizona, a wheel-to-wheel racing class. We actually put it together with a high compression, naturally aspirated C-Series, ITBs, all that fun stuff. And it was very competitive. We ran it for 2 years. We won the championship in 2015, which we're really thrilled with. After that, I stopped doing as much wheel-to-wheel racing and was more focused on time attack and just going fast and having fun, which presented some problems with the C-Series. Primarily, it's extremely expensive to maintain and operate and keep going, and if it ever catastrophically fails, it's at least $20,000, $30,000 to get back on the road. So that's when we came up with the idea of taking a different path.
Now, tell me about some of the exterior modifications you had. I mean, it's different than it was when we first started, but
sure.
Tell me about the suspension. Tell me about how it was when you were racing in the class in NASA.
So when we were first doing wheel-to-wheel racing, we were running a pretty basic Fortunato Dreadnought setup, which was developed bespoke for the car. It was awesome. We really enjoyed it. We started with Willwood brakes. We moved over to StopTex a little bit down the road. It was still factory body at the time, not for any real reason other than just that's what we had, so that's what we ran.
Mm-hmm.
So over the last year, we decided to wide body it, and mainly for the front end. These cars are notorious for not having enough room for tire in the front.
Got it.
So the biggest tire we could fit prior to this was a 245,
mm-hmm.
And it was a fairly tall one, so the contact patch was actually kind of short. So now we've stuffed my old rear tire in the front, which is a 265 35/18.
Nice.
So it's changed dramatically how the car turns in, and that's what we've been really trying to figure out for years. We've actually put a 295 in the front as well, but to make the 295 work with the scrub radius is what we're worried about, is that it's actually going to touch in the back by the fender liner area.
Right.
So we'd have to box the car in to really effectively use that. So we've stuck with this 265 for now. We also switched to the motion control suspension from MCS. Not really any major reason there. There was nothing wrong with our old suspension. I just like to try things new, and the whole car is fresh to me at this point, so we decided to take a different direction with suspension as well. And so far, we're really very happy with the changes. We went to a three-way from an old two-way setup, so this is the first time we've had control over low and high-speed compression. So that's the next major step, is actually tuning this car for Super Lap next year. We got a lot of work to do on the suspension now that the power plant's happy.
Yeah, so what about aero on this car? What have you done for aero?
So we did make some changes from the last time you saw the car on aero as well. So we had a very large opening front air dam on the car prior to this setup. Mm-hmm. But and that was really great for front end grip, but caused a couple problems. Tons of drag. The car was very draggy. We ran it through CFD, and we could see how much high pressure was being built up around the nose cone, mm-hmm. and how it wasn't actually able to evacuate it through the hood vent or any kind of efficient way. And then on top of that, we didn't have the power before the swap to cut through that, so it really killed a lot of top speed. So big tracks like COTA, Road Atlanta, the car would top out like 140. It was really, and it took forever to get there too. So we actually ended up going back to an OEM front bumper and sealing in the lower lip with a much more mild splitter, which so far locally at tracks with about 2,800 foot straightaways, we've been able to hit 140 plus. At Long Beach, we hit 140 plus, and that was with this setup as well. So those are two huge pluses. And the other thing we had a problem is, funny enough, the car was overcooling.
Oh,
we actually couldn't.
That's right.
Yeah, we couldn't keep the car at above 160, 150 degrees, and that was with a thermostat still, and it would just open and you see the temperatures rise up, and then the thermostat would slam shut, and it would just ice cold immediately. So switching that mouth to a smaller size mouth helped with that in terms of inside there's a duct that actually allows the air column to slow down, so it still gets a lot of volume, but it's actually coming in at a much more decreased rate. And then we also put a bigger air-to-water intercooler in front of the radiator to, again, slow down the amount of airflow going through the radiator, because we're using this massive radiator, which is a bronze-based radiator, which has a very high thermal mass. And it's wonderful. Like, it's crazy that this car literally never gets above about 210, even when it was 90 degrees out. We were doing testing at 200, and we got to 210 degrees. With our prior aluminum radiator, it was sitting at 230, 235, which isn't extremely dangerous for this engine, as we found out.
Right.
It's pretty normal for these K20Cs to run a little bit hot. But for my mental sanity, seeing 210 is a lot easier than seeing 230 plus all the time. So it brings it down to about 210 in the 90-degree weather. At Long Beach, it didn't get above 195.
You also mentioned that these massive radiators are a lot more even, so
right,
you're not finding the dips in the peaks
so
like you would.
the aluminum radiator we had would actually change temperature quite a bit more rapidly. It would cool down quicker. It also increased temperature quicker. This bronze radiator, we've noticed that the temperature pattern is very consistent and very even. It swings within a very small range of temperature. The window is much smaller. The aluminum radiator, it would sit anywhere between the thermostat temperature, which is 176, up to, like I said, 235, and it would be anywhere in between there, which is it was really frustrating to watch, because it was I never knew if we were having a pattern of upward increase, if I had a failure, something like that. Where this one, with this setup and the way we've got it set now, it usually sits at about 185 to about 205 to 210. Nice. So it's just a lot easier to watch. So I know if it goes past 210, something's up.
I know the K-Series engine, at least with the stock ECU, changes the tune dramatically depending on the heat of the engine. So this radiator should actually help smooth that out, and if we were running a stock radiator or a computer setup, it would probably help out quite a bit with the tuning. It'd be a lot more consistent throughout a lap, throughout, you know, differences in the day at the track and stuff like that.
And I think you mentioned when we were putting it together, I think we found out the factory overheat was like 250 degrees or something like that. It was pretty high. So again, it's keeping it 220 and lower. Really a major goal for us to be able to not look down at the dash very often. I mean, we have a bunch of alerts set up on the dash for when things go a little bit out of control, but it's just like I said, most Honda owners do not like seeing 220 plus, regardless of the platform.
Yeah, absolutely.
So it's nice to have that radiator doing a great job for us.
Yeah, it can really change things dramatically.
Yeah.
All right, so let's take a quick look at the interior of the car and let's see how it's laid out.
Obviously, an extremely minimalist interior. The original goal was to do ST2, which for ST2 to make this car class well, we were 311 horsepower at the wheel with a natural aspirated engine, but I'm competing against Mustangs with 400 plus horsepower with a lot more legs up top, so the only thing I could do is to reduce weight. So the car, as it sits with me in it, and a tank of gas, and the driver, is just a touch above 2,400 pounds.
It's good. These things are really actually quite light.
Yeah, once you take all the luxury equipment out of them, all the power seats, all the stuff behind the dash, I mean, and then we went to the length of, obviously, with this swap, we were able to do a custom engine harness, which there's only like 10 wires that run to the front of the car, essentially for the dash and for the keyboard, and a couple of little things, brake switch, clutch switch, stuff like that, and then the fans. But all the extra mass and wiring, the ABS, and all that stuff's been removed for a minimalist mentality, which, you know, if we were doing this swap back then, we may not have even gone that route, but it just happens to be already done. So that's why we started with a pretty lightweight chassis. So
very good.
Inside, just the dash panel with alerts, steering wheel, and a keypad to start the car, and then the cutoff switch and the shifter. Really, the dash is required to be in there for classing, so we had to leave the dash in there. Otherwise, that would be gone too.
Let's look at the fun part, the engine swap. All right, so what we're looking at right now is we're looking at the K20C4, which is the Accord version of the Type R motor. It's a little bit different. It's got a few different part numbers on it, but it is externally the same dimensions. Now, you actually went and sourced out a Type R transmission for this, didn't you?
We did, and as we put a Type R transmission on it, mainly because it came with the LSD right out of the box, which we didn't want to mess with. And I know we actually fitted the K20C one originally in here, and then we decided not to go that route, mainly because these were more available. And as far as we can tell with part numbers, they're basically the same except for the compression, the turbochargers, and the electronic system.
Correct.
So we knew we were ditching the turbocharger anyways, because Full Race was able to provide us with a Borg Warner turbo. With the actual, it's actually just the Type R turbo kit that they sell off the shelf. Bolts right on here, fits perfectly. It's got a few millimeters of clearance in the front, so not a huge issue there. And then the other obviously big difference was the electronic system. So the Accord uses that key hand system, I believe, versus there's a Bosch system on the
Type R.
Type R. So some different challenges that hadn't been addressed yet. No one has done that before, but we were able to get through that fairly easily with the help of yourself and Honda and Honda
Yep.
with getting diagrams for everybody.
Yep.
And to me, that ends up putting us in a package that I could pick up this engine for about $2,500 usually is about the going rate for these blocks in the junkyards with like 9,000 miles on them. So for a car that we're going to beat the crap out of all the time, it makes way more sense to have a plentiful supply of cheap engines versus the Civic Type R, which, hey, we're removing the turbo already, we're changing the whole electronics package. Basically, we're just paying for the name at that point.
That's right. Yeah, so if there ever was a problem with the engine, it would be so cheap to replace it, it's not even funny.
And you know, it's even come across my mind as like, if we were to blow it up in like Texas, I could probably go to a yard and get one. Like just go down to the local yard and get an engine the same day without even bringing them. Whereas finding a Type R in any city is a little hard because this engine's in every 2018 2.0 turbo Accord.
That's right.
And do they have it in any other engines, or is it just in the Accord?
RDX.
The RDX uses it as
Yeah,
well?
and I think the TLX, not the Type S, but the base model TLX currently has the same motor in it as well.
And that's important because one of the things we thought about when doing this entire build was serviceability, because the C-Series serviceability at a track is actually quite awful. I mean, almost everything's engine out, unless it's a coil pack or a spark plug related issue. Almost everything else is a complete engine out scenario. Now, this is still an engine out scenario, but the key difference is as you saw at Superlap, we can get this engine out in about 3 hours on jack stands.
Yeah.
We actually had a clutch failure at Superlap Battle, so we ended up doing a clutch job at the track for its very first event, and it took 3 hours to take it out, 3 hours to put it back in, which is about, well, I would actually say it's almost impossible to do that with a C-Series. Couple problems, getting it high enough to actually get the trans out. It's difficult. We've done gearboxes at the track on a C-Series. It's not fun. It was actually easier to pull this entire engine than it was just to do a gearbox on a C-Series. And then the other thing, obviously, is when we were able to design this whole thing, we designed it so everything was on top of the engine on this side, so that way you kind of leave everything behind. The engine just drops out the bottom. All the peripherals are left inside the car. All the wiring just flops over top of the engine. Take the turbo, put it on top of the engine, and just disconnect the intercooler and disconnect the downpipe and exhaust and drop it out the bottom.
So all in all, I think this as a race package, if you're running an NSX, I mean, obviously if you want to run the NSX engine, you're going to run the NSX engine. But, you know, this winds up being probably the only swap choice for this particular car. You know, I mean, you could do a J.
For what it's worth, like I said, the C-Series undoubtedly has a better sound.
Yeah.
The C-Series sounds amazing. I had my white stock NSX with a GLTC exhaust, and the lightweight exhaust, and I love it. It sounds amazing. This sounds really good, though. This doesn't sound like a typical K-Series with the exhaust knocked off. You know, like this thing, even when we have an exhaust leak, it sounds amazing with an exhaust leak. It's a nice tone. That's the only thing I'll ever really miss. But past the sound being different, being able to get inexpensive power, like getting 500 horsepower of these stock is fairly normal. That's very doable. It's a well-sorted path, especially with a secondary fuel injection like this one has, and running ethanol. And then the fact that, unlike the regular K-Series, this comes pre-turbocharged with internals that can handle it, so you're not building the engine separately. You're not building the gearbox separately, I might add as well. Because regular gearboxes on the standard K-Series, a lot of them have a lot of third gear, fourth gear problems, I've noticed. Stock, even at like 200 horsepower. Well, we're running over 400 through this thing, and I'm not known for speed shifting. I shift fairly normally, but I'm not losing gear sets. I'm not getting scratches. We're going to try to push it to 500 and see how it handles tracking at 500. I mean, it's cool that it's already liquid cooled. The transmission already has a cooler built into it. There's so many pluses of this that I didn't have to add anything on, because essentially what we have here is a stock K20C with a stock gearbox and an aftermarket turbocharger and then an ECU, and that's it. It's stock, and it's been running phenomenally.
I think it's an awesome choice, and Carter was telling me you offered us a chance to maybe drive this.
Yeah, I'd love to have you guys take it out at one of the local track events, or come down to Podium Club.
I think Podium Club. I think we'll go down there.
I'm pretty sure I can get you into the track at Podium Club for some demo videos. Those guys love to see cool stuff show up and run around out there. And
nice.
It drives very differently. Even from the last generation of this car, the K20C completely changes how you drive the car because of the torque coming in at 2,500 RPMs. You've got 400 pounds of torque now, and you don't need to wrap it out. Everybody's like, "Oh, you missed the RPMs." I'm like, "Nope, I just short shift the crap out of this thing all the way up the rev range," and it's taken quite a bit of learning to re-educate myself on how to drive this car, getting on the throttle way earlier than trusting that it'll stick, because it doesn't even spin up the rear tires because it's a heavy rear car. You know, it's a rear engine car. It's very heavy in the back, so it's not typical when you smash it in a car with 400 pounds of torque and it starts oversteering. It just grips and goes, and if anything, you still have to deal with understeer.
Very good.
It's very interesting. So yeah, I look forward to taking you guys out there with it.
Nice. I noticed you have an air-to-water intercooler, which I think is probably going to be a necessity on these cars just because of the routing of the tubing and stuff like that. It would be difficult to get.
I mean, you could do like a side mount air intercooler like the MR2 uses, but there's just so much heat in the engine bay that just doesn't make any sense at all. So yeah, we had Wild Child Innovations out here in Tempe make this intercooler, air-to-water intercooler for us. It's using a Garrett core. Thankfully, Tony recommended that Garrett core to us because it's been very critical and very solid intake air temps on here. So basically a piping system goes around the front side of the turbo, comes up into here. 2 hoses right there. One goes to a reservoir in the back. The other one sends that water up to the front of the car where we have the air-to-water intercooler heat exchanger actually mounted, which is fairly large. It's about the same size as a radiator. Again, we did that just to block some airflow and also to, again, have more capacity on the air-to-water. So 90-degree days, we were seeing about 120-degree air intake temps, which is pretty low for as hot as it is out here in Phoenix and a turbocharged engine. In the winter, we were seeing really close to ambient, actually. It was 10, 15 degrees above tops. Right now, it's only got a 3/4 gallon reservoir. We're actually going to add a 2-gallon reservoir in the front as well to add more capacity, and also so I could add ice water a little easier.
That's actually not a bad idea.
Yeah, because our main reservoir is in the back for bleeding because of the height, but that also makes it really hard to access because the wing is a bolt-on wing and it goes through the trunk lid there. So a little bit of a challenge, but also a little more weight in the front wouldn't hurt anything. So
yeah, exactly.
And the other thing we did is we had the axles custom made by Drive Shaft Shop.
Right.
So you were able to come over and measure everything for us. We simply sent that into Drive Shaft Shop, and they sent us a working axle. First prototype, bolted right in, works great. No
Thank you, Drive Shaft Shop.
Appreciate that, guys. Made it easy.
Really did. That's good. So there's some other parts that are going to have to be custom. There was some water routing for the radiator.
Right.
Did you wind up making changes at the engine or making changes at the water pipe?
So our whole point of this was to make it where the chassis doesn't change as much as possible. And I can confidently say I don't think we actually changed anything on the chassis. This is still an NSX chassis, uses NSX mounting points for everything. So we left all the water necks the same. It uses the factory water tubes all the way up to the radiator, so that entire system is all NSX. What we ended up doing is we made a water block that goes onto the side of the Civic Type R and the Accord engine. It'll go on either one. We test fitted it on both of the engines. Simply intercepts the water neck coming off, and it diverts water to all different places. So it's got water going to the radiator. It's got water going to the to the oil cooler. Then it has water going to a couple of the other places like the reservoir and the turbo, and it's all plumbed into one water block. We did a couple revisions of it, but essentially it's 4 bolts hold the whole thing on, and then there's 6 AN connections. And so to get the engine out, just unbolt it from the engine and leave it hanging there.
Oh, nice.
It's really nice. So we did that development mainly for, again, serviceability, quick, easy use. Seen a couple other complex ways of doing it, but at the end of the day, this made the most sense because it stays with the engine. It doesn't modify the engine or the chassis in any way. So we're really happy with that.
Oh, very good. Excellent. You did a ton of work here. I mean, basically, I got the motor in the car, and I was pretty happy with where it was sitting, but you wound up doing all the heavy lifting.
Well,
you know.
I mean, and it just wasn't just me. I mean, don't lift.
Yeah.
The real heavy lifting, that was Don Brown. Don Brown and Tony at UMS did the actual heavy lifting. Because, yeah, I put it in there, I routed stuff, I made stuff fit, I did all that stuff. That's, anybody can do that. I mean, it takes time, but realistically, that's a skill that anybody who does cars and all of our enthusiast friends could have done that. Making the mounts was very, very key, but the wiring harness. So Don Brown did all that wiring with the help of Tony at UMS and obviously some guidance with you and some diagrams from some other folks, but I think he's got something like 80 to 100 hours in developing that harness, because as you saw, the wiring diagrams for this engine and these series of engines is basically
crazy.
They're just spaghetti going everywhere. There's 190 some odd wires on the factory harness, and it was insane. And we had to figure out what we did need, what we didn't need. The diagrams have a bunch of symbols on them I've never seen before, because they're not like the old 90s Honda diagrams that are just really straightforward. Power, ground, 5-volt, power, ground. No, there's all these weird variable resistance and all these kind of things that we had to all figure out. I remember Don and I scratched our heads for days trying to figure out how to get this thing to work. And once we got it all plugged in, Tony went through it and he got it to fire up after finding out, again, a lot of key differences that weren't in the manuals, just like timing triggers and things like that. So I think that was the most work, was by far the wiring. And now I know you're working on solutions to make that a lot easier.
Yeah, what we're working on is talking about using the stock Gaghagen ECU, and then actually going into the ECU and having a lot of the communication codes and other codes that are really not necessary to put the engine in an older car, having those eliminated from the ECU so that the car will run like a Honda, with the exception of its communication back to VSA and the body control module and the dash and stuff like that.
So the main reason we obviously went with the MoTeC was mainly because A, that was a very easy solution, but B, because we wanted to run the high and the low pressure system. So we're running the 4 ID injectors up on the top of the rail, and then the 4 direct injectors on the bottom of the rail. Now, without the MoTeC, you'd either have to pick one or the other. You'd have to weld the direct injection shut, and run just port injection, or run no port injection and just direct injection. Then you have to get the pump upgrades and quite a bit of other things to get power out of this. So for us, knowing that we were going to go 400 plus north of that, going eventually to 600, having port injection is very important.
Right.
So that for us was the solution with MoTeC, and where the factory ECU was going to be a limitation. But if somebody's looking for staying under 450, I think the factory ECU is probably the way to go.
Fine,
yeah, it's probably the way to go. You can probably get away with it just with the direct injection pump. I think there's a couple offerings out there already for
that. So that brings up an interesting point. If you're running an Accord motor, you're not going to be able to run the boosted pump. Because what winds up happening is the ECU actually controls the pressure. So it's going to be more like a Type R swap. So there is some, there are going to be some ECU choices for the Type R motor coming out of a couple of different sources, hopefully one of them using the stock Bosch ECU, but with the Accord motor, the Accord motor is going to be limited to what an Accord can make. So you can't really do an upgrade on the fuel pump because there's no control of that particular fuel pump, built into the ECU.
So if you're going to use the,
but I'm sorry, but let me change that. So what's interesting is I'm not sure what's out in the new Type R. There's rumor that the new Type R is going to be using a Gaghagen ECU rather than a Bosch ECU.
So that might be some future endeavors.
So if that's the case, that might wind up being a viable option. So we're just going to have to wait and see.
I mean, I kind of imagine most folks who are going to be doing the C4 option are probably going to be doing track days a lot, because that's a big concern, is the availability and the easy access to the C4 versus the C1, and then just the cost difference. Because for me, the C1, the advantage would be is if you're going to do a C1 into this car, it's because you were going to leave it stock. You're going to plug it in at 300 and 300 and just enjoy it the way it is, which would make a lot of sense, because it's better than the factory output. It's way more torque than the factory output. Plus, you can get a 6-speed upgrade if you're in a 5-speed car.
Yeah.
So that's just a win-win-win there. But the C4, to me, with the MoTeC, gives you just a lot more headroom to work with, and then a lower cost of operation. So if you're planning on doing a bunch of racing or doing drag racing or something where these are going to be disposable, paying for $5,000-6,000 for a used Civic Type R engine doesn't make any sense, when really you're only using the block essentially, because you've replaced the turbo, you've replaced all the other good stuff on it.
And you really should be going to not port injection, but to the manifold injection and stuff like that. So yeah, obviously a MoTeC or equivalent would be the choice there.
It's really going to depend on which way the owner wants to go with the car, what they're going to use it for.
Exactly. Now, we did mention the fact that this actually has a Type R transmission. The Accord transmission the cases are almost identical. It just lacks the cooling and the LSD.
Yeah.
But what was kind of interesting was getting it to shift.
Yes. So obviously, when you put a front-wheel drive engine in the back of a car, the shifter cable routing becomes an issue, and there's a tank in between, so
we couldn't
there's not a lot of easy ways to put the shifter in the way it's supposed to go. So we ended up using, it was a Accord or a Prelude shift box was our base point, right? I think it was a Prelude.
Prelude.
It took a Prelude and
9047 Prelude.
Yeah, then we flipped the gear selector 180, right?
Yep.
We flipped that 180, and that was the solution. And we would like to make a finalized version of it, because we figured out, man, somebody needs to make a shift box that flips 180 just from the factory, because then it can power anything.
Exactly.
I mean, that would be, we need to put that on the to-do list.
I'm going to try and figure out how to make kind of a universal
Right.
shifter, so that not only will it not only will it flip the functions, but it'll, I mean the right-left function, which is what we had to do with this, but I want it so it can also flip the push-pull function.
Right.
Because then it could be really universal.
Yeah,
so,
I mean, I've looked at it a few times with K-series shifters. I haven't understood why there hasn't been one that's completely reversible in all directions. Because when we were doing this, I went through all directions. I tried the stock NSX shifter, figuring out what we had to flip. Then we did the Prelude one, figuring out what we had to flip. And then the nice thing about this setup, though, versus trying to make a NSX shifter work, is it allowed us to run the cables in the factory manner. They do go around and behind the transmission, and we put a bracket on the transmission to accept them. This was by far the most cost-effective way because it didn't really require anything custom on the cables. The cables I only paid like $115 for, and I just got them from a standard cable company. There's no custom ends on them or anything. I just ordered them with the correct ball sizes on them, and that was it. So that was actually the least expensive part of the whole project. Everybody's asking, what kind of cables you use? I'm like, I got them online. they're just cables. So that was one of the easiest parts.
Yeah, exactly.
Yeah, they're this long with this size head on, and they have this much throw. That was all it was. The bracket that you made worked perfectly, and the cables I got are adjustable, so you can adjust it slightly in terms of how it feels. And if
I'd have guessed wrong.
Yeah. If our measurements weren't quite as good, we could have played with it, but I didn't actually have to. I ended up putting them all centered right on their adjustment points, and they work perfectly fine. The throw's nice. Feels very similar to the factory NSX throw, actually.
I enjoy it. I'm driving around. I was impressed with how.
Yeah, it feels real light.
Yeah, because I remember making it, and I didn't have the car here, and I'm making this stuff, and I'm like, well, here you go. Try this out.
It turned out okay. Like I said, I played with the lengths a little bit just to make sure that it shifted in the right, so it wasn't all the way over to one side. Remember, at one point the shifter was way over here to the side.
And
we changed it and adjusted the bracket length, which brought it back to about where it is. I'm actually looking for a factory center console to see if it'll just slip over it, and see if it'll just put it right back where it was. And that's the next little boredom project, I guess you might say, just for my own aesthetics.
Very good. Yeah, so what material is this?
So this is dye bond. It's commonly found at like sign shops, places that sell Alumilite, same thing. Alumilite though is different because it's corrugated on the inside, so it's quite a bit lighter.
Really lightweight, yeah.
Really lightweight compared to this stuff, but the problem I was having is that it was so lightweight that it needed so much support everywhere. And this car doesn't actually have a lot of anchor points in the front to run supports from, mainly because there's no beams up there, and then there's just the two frame rails. That's it. So everything had very high angles when we ran supports with Alumilite.
Right.
We had also tried CRP, which is what we had on for Long Beach, which again, that worked really well. Supports a lot of load very far from the actual mount points, but the weight was nuts. It was really heavy. I think it was something like an 80-pound splitter. This is about 30-ish. And then the Alumilite was about 12.
Okay.
So this has been a really nice balance between, this is a nice balance between strength and then weight.
Okay.
As always, I don't really complain about putting weight on the front of this car because the more weight it has over the nose and front of the tires, especially the better. So it's been good so far. We're probably gonna make another version of it. Obviously, we put this on before we wide-bodied the car. So we'll make a slightly wider version for the wide-body car and probably add another inch around the entire perimeter and then end plate it as well and put air dams for the wheels. Yeah, air dammer for the wheels.
Okay, very cool. All right, well, this car is pretty freaking amazing. All right, hey guys, thank you very much for joining us on this tech inspection of Ravi's NSX, and I hope you enjoyed it. Please think about liking and subscribing. We're like this close to 75,000 subscribers, and we're gonna try and put a push on to 100,000 subscribers. So once again, thank you very much. And I'd like to have you back on a Tuesday Night Live, not this one, but maybe next one.
Sounds good.
All right, cool. Thank you for coming down.
Thank you.
All right, we'll see you later, guys.